Hello friends, class I start with the hardware component of the IoT, right? Sensor and actuator, these are the main hardware part of the IoT components. And apart from the sensor and actuator, this I have already discussed, right? So apart from the sensor and actuator, you will have the some other hardware components which are required for designing any kind of the IoT device. Okay, so what are these other components? One is the microcontroller. Okay, so one is the microcontroller. A microcontroller, that is one of the heart of the IoT device if you want to design IoT device. Okay, microcontroller, it has to complete it. What is the task of the microcontroller? It can complete the specific task. Okay, so in various application you can use the microcontroller. In computer also you can use microcomputer, but for the purpose of the microcontroller is to do the specific task. Okay, now in different embedded system you can use the microcontroller like washing machine, refrigerator, micro oven, and various application you can use the microcontroller. Normally microcontroller, it has to perform specific task. You can also use this thing in the IoT device. Okay, and what are main applications of this thing? Washing machine, okay, microbe and refrigerator. So many things are there. I'm not writing here. Okay, now come to the another part of the microcontroller. So mainly microcontroller and microprocessor is also there in computer. You can see, but microprocessor has various tasks, but in case of the microcontroller, it has only one task. It can complete only the one task, right? So if various application you need various kind of the circuit, right? So for based on the application requirement, you can use the only one microcontroller which can be used for the one specific application, IoT application. Right. So if you want to design any kind different kind of the IoT application, you need to take another microcontroller based hardware. Okay. So next is the CPU. Next is CPU. CPU, the full form, I think all of you know, which you have studied architecture, computer architecture, and microcontroller subject. The central processing unit. Okay, this is the brain of the microcontroller, right? This is the brain of microcontroller, right? So it can execute code, okay, or program. Is a code or program. Okay, it can fetch instruction from there is a CPU, central processing unit. You have the lots of register. You can store the data and you can execute the program. And you can do the arithmetic operation can be performed in the central processing unit, and it can also transfer data. Okay, it can also transfer to the other peripheral, external peripheral, and it can also receive data from the external peripheral. So it has a capability to execute some kind of the code, and which is inside in the microcontroller. Okay, and it can transfer data to the peripheral device, and also it can transfer data from the peripheral device. Okay, so this is about the central processing unit on microcontroller. Next, come to the memory. Now come to the memory. Okay, so memory, it may be external memory or it may be internal memory. So in case of the microcontroller, it will not, it will have also internal memory. So there are the two types of the memory. So one is the program memory, another is the random access memory. Okay, so program memory Another is the random access memory. Okay, so this memory, it may be internal or external. If you use the microcontroller, so for specific microcontroller some specific size are available. Suppose for program memory, normally suppose 4 GB is the 64 GB memory size is there, but for random access memory suppose 4 GB memory access there. So but if you need the more than this size, okay, you can connect the external memory along with the microcontroller. Okay, so now come to the program memory and the random access memory. Where you can use these two kinds of the program memory, that is mainly for permanent use, and random memory, that is for the temporarily. Okay, so when you execute, when you want to write the program, right, at that point of time you can use various kinds of the variable. Okay, so for if you declare the variable, that can be stored inside the random access memory. So while writing the program, you need to store some variable in different register. So this for this purpose you need the random access memory. So when you switch off the power supply, so whatever thing you have stored inside the random access memory, that will be delay. Okay, you cannot restore those data. When again your power is on, so you have to reset all that thing. Okay, so that is random access memory. So this is for temporarily. While writing, if you want to store any kind of the variable, for that random access memory is required. Okay, this is volatile. Okay, whenever power is shut down, so you cannot store any kind of the data inside the random access memory. During writing code, you need the random access memory. So once you write the code inside the program memory, you cannot modify. Okay, that's why for modifying purpose, for manipulative purpose, you need another memory, that is the random access memory. And now come to the program memory. So program memory, that is also known as the read-only memory. Okay, program memory or read-only memory, ROM. Alright, so after executing the program, if your program is correct, okay, so there is no bug and no error, so you can store this program permanently in the program memory. Okay, so it will not delay. If you shut down the power, it will not delay. Okay, so whenever some applications are required, so you can call that program, you can execute, and accordingly the program will be executed, you will get some output, right? So for that, program memory is required. So that means you can store here, variable can store, variable can store, this is volatile. Here you can store program, and this is also this program memory, this is non-volatile. Okay, here also you can store program, but it is not permanently. You can manipulate. For need to manipulate the program, you can store in the random access memory. For permanent purpose, you can store this program inside the program memory. Okay. Now come to the input output pin. Okay, input and output terminal. Okay, so inside the microcontroller you will have the two different kinds of the terminals, that is the input terminal and the output terminal. Okay, so input terminal, okay, that is defined as a read terminal. Okay, so here collecting data from other device, collecting data from other device to IoT device. Okay, and another is the output, that is also defined as a write terminal. Okay, here what you can do, you can transfer data from IoT to other device. So suppose through the hardware, there is one platform. Through the hardware platform, you need to transfer the data like digital data, data one or data zero. Okay, for turning on the LED, for blinking LED. Okay, you need to transfer the logical data one and zero. So for that, you can use the output terminal, digital write. Okay, this is called as write terminal. And the input terminal, if you want to take the LED data, okay, from LED to the processor. Okay, for that the input terminal is required. Okay, that is also defined as a read terminal. Okay, now next is the come to the main part, another part of the hardware component, that is the various kinds of the breadboard or various kinds of the board you can use for processing the data. Okay, so I have told the microcontroller. So microcontroller, that is normally inside Arduino. Inside the Arduino, you can see the microcontroller. Okay, this is a one-time open source software hardware platform, right? So this is Arduino. You'll have Arduino Uno. Uno is the one type of the Arduino. Okay, it is a small board. Okay. This Arduino Uno is a small board. This can be integrated in another breadboard. So why the, because this is a small board, you cannot connect the lots of devices along with this Arduino Uno. So if you integrate this Arduino Uno with a big board like breadboard, you can connect the lots of devices for various applications. So you can integrate the Arduino Uno other devices inside the breadboard for various applications. So Arduino Uno, the software version is the C++ is applicable for Arduino Uno. If you want to write any kind of the program, so for that C or C++ is required. C and C++, there is a sketch platform inside the Arduino software. So inside the sketch you can write the C++ code. So if you see the C code, it has the two function. One is the setup function, another is the loop function. Okay, the setup function is execute one time and the loop function is execute multiple times. Where how long the power is turned on, so till that period of time the program can execute and set the loop. This I will discuss in the upcoming lecture also. In the setup function, suppose you want to connect the Wi-Fi internet, so Wi-Fi settings and connectivity, this you have to write inside the setup function. And input output terminal is also, if you want to configure the input output terminal, that also you have to write inside the setup function. And the loop function main program, the process, what are the process required, how the program will be executed. Okay, so if you want to transfer the data, you have to retrieve the data, this kind of the portion you have to write inside the loop function. Okay, so this is about the Arduino Uno. This is also fast processor. Okay, Arduino Uno is one type of the hardware component where the microcontroller is inbuilt. There are various kinds of input output terminals are also available. Apart from the Arduino Uno, there is another board that is called Raspberry Pi. Raspberry Pi, it is also known as a Raspi. Okay, so here the Python language. When you write code under the Raspberry Pi, you have to write code using the Python language. It has a high processing power and processing memory, so which can incorporate web server. It can incorporate web server and it can also execute Windows 7. Windows 7 can easily run inside the Raspberry Pi. Okay, it has a high processing power and processing memory, right? So that the Windows 7 can easily execute on it. Okay, and it can also incorporate web server, and it has the capability to write code using the Python. Right, this is about the Raspberry Pi. It has a different versions. One is the full scale version, one the small Pi Zero version, one another is a compute module. Okay, it has another version, that is compute module. Compute module. It is normally used for designing the IoT device, that is compute module. Okay. Next, last time I want to discuss the Brangle board. Okay, BEA Brangle board. Okay, So it is based on the single board, integrated board. ARM processor is also there, and it is Linux based OS. So it is also most powerful than as compared to the Raspberry Pi, as compared to the Arduino Uno, right? So what is the difference? The single board ARM processor, it is also like a computer. Okay, it is also like a teeny computer. Single board ARM processor and Linux based OS. Okay, so these are about the hardware part. Now next class I will start with the software part of the IoT device, and coming lecture I will discuss the Arduino portion also and Raspberry Pi. How can you write the program on Arduino and the Raspberry Pi? So thank you for listening my lecture. So please like, share and subscribe my channel.